Hello students, welcome back to today's class on whole numbers, and today we're going to have a practice session. We're going to learn few tricks on how to multiply large numbers or how to divide large numbers using properties of whole numbers, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session and let's see what is the first question. So the very first question is the 437 into 102. So how to solve that? So I'm not giving you any hint, so please try to solve that in whatever logics or whatever tricks you know, or else just go with the normal multiplication. Okay. So after that, I'll tell you what is the trick behind that, how to multiply these two very simply. Right. So please try that. 437 into 102. One thing for sure, 7 into 2, the units digit should be 4, and that is there with all the options. So we cannot eliminate any option, correct? We cannot eliminate. The 7 into 2 is 4. Had it been only one option is with ending with 4 and all the other options are ending with the different numbers, then directly without any multiplication we can directly say that that is the answer. Okay, units digit. But now as all things are equal, so please try to do it fast. So I think you have got some answer, but it is a very lengthy process and also time taking process. You need to multiply 3 digit into 3 digit. Okay. So 437 into 102. Let's see that. 7 2 is 14, 3 2 is 6 plus 1 7, 4 2s are 8, right? You know multiplication, the same process. Had it been 3 digits or 4 digits, 5 digits, everything is same. Just leave this place now and start with the next place. 7 zeros are 0, 3 zeros are 0, 4 zeros are 0. And once again leave this space and go with the last one. 7 ones are 7, 3 ones are 3, and 4 ones are 4, right? That will give you 4, and this is a 7. 7 plus 8, 15. 3 plus 1, 4, and this is 4. 4, 4, 5, 7, 4. So that is with option B. 4, 4, 5, 7, 4, right? But I'll give you a small trick here on how to solve these questions. Very easy. And you can see 102 is a number very near to 100. Very near to 100. Okay, so 437 into 100 I can write as 100 plus 2, because multiplication with 100 is quite very easy. Just keep the zeros. Okay, so now how to split this one using different properties of whole numbers. You need to multiply 437 with 100 as well as with 2. Okay, so 437 into 100 plus 437 into 2. So the only thing you need to multiply a very small number is 437 into 2. Because this is not a difficult task, this is directly 43700 plus, so 437 into 2, 7 2s are 14, 3 2s are 6, 7, 4 2s are 8, so 874. Just try to add these two, 43700 and 874. So this is 4 7 15 and this is 4 4 4 4 5 7 4, right? So in this process, if you're very clear, no need to do all this. You just need to multiply 437 into 2. Just this multiplication into 2, and you need to add to 43700. It will be taking just 20-30 seconds instead of calculating the entire multiplication, correct? Right. So what is the answer for that? 4 4 5 7 4. So that is option B is the correct answer. So let's try to move for the next question. 925 into 99. Once again, please, I'm giving you time. So please try to use whatever the tricks you can and try to do it as fast as possible. The point here when we're trying to learn all this is everyone are clear with the normal multiplication, but we need to have some tricks to calculate that more easy, right? So please try to solve that fast. Last 30 seconds more. $20 seconds more. One thing I can say here, 9 into 5, the last digit should be 5, 45. So this option will not be the answer. Any of these three will be the options, correct? Right, so we're almost done with the time. So let's try to see how to solve this question very easily. Instead of multiplying with 925 to 99, we write 99 as 100 minus 1. 925 into 99 is 100 minus 1. That is the most easiest thing that we can do. Right. So 925 into 100 is 92500 minus 925 into 1 is minus 925. So 92500 minus 925. 92500 minus 925. Okay. So this is a 10. This is 9. This is 4 and 14. 1. So it will be 5. Then 7. Then again it is 5. 91. 91575. So do we have that option? 91575. Once again, please cross check that if there is any calculation mistake here. Just try to give the correct option accordingly. Okay, so that will give you option D as the correct answer, 91,575. Right. So let's move for the next question. I'm so sorry, I'm not feeling well today. Right. What is the next question? 1, 2, 3, 4, 5 into 15 minus 2, 4, 6, 9 into 25. Right. So here you may ask me, sir, what is that logic behind this one? Do we have any common things like 100 or 10, 20, 30, what anything with zeros, right? So as soon as you see that, you may not get to know that trick behind that, but please try to find some some relation between 1, 2, 3, 4, 5 and 2, 4, 6, 9. So that will help you in solving this question very easily. Just try to bring some relation between 1, 2, 3, 4, 5 and 2, 4, 6, 9. Last 30 seconds more. Twenty seconds more. Right, so we are very near to 0, last 10 seconds. It's a very easy concept that to bring some relation between 2, 4, 6, 9 into 1, 2, 3, 4, 5. As far as I know, let me let me try that. 2, 4, 6, 9 into 5. Let's say try to find 5. 6 9s are 45, 5 6 are 30 and 34, 5 4s 20 and 23, 5 2s 10 and 11 12. So 1 2 3 4 5 is nothing but 2 4 6 9 into 5. Right. So that is enough to take 2 4 6 9 out common. Once again, let me write that question properly. 2 4 6 9 into 5 into 15 minus 2 4 6 9 into 25. I'm writing it as 5 into 5. Okay, 25 I'm writing it as 5 into 5. So that I can directly take common 2 4 6 9 into 5. Right. So if you take a common 2 4 6 9 into 5 common, so I left it 15 here and 5 here. So 15 minus 5 is 10. So that is very easy to multiply. Correct. So 2 4 6 9 into 5 into 15 minus 5 is 10. So 2 4 6 9 into 5 we have already multiplied, that is 1 2 3 4 5. So 1 2 3 4 5 into 10, that will give you 1 2 3 4 5 0. That will give you 1 2 3 4 5 0. So that is option D is the correct answer. The only thing you need to understand in these type of questions are, these type of questions are really not there to ask you how well you can multiply each and every term. No, we need to understand the logic behind that, and based on that we need to solve accordingly. Right, so that is option D. Let's move for the next question. Write the smallest 3-digit number which will not change on reversing the digits. Smallest 3-digit number which will not change on reversing the digits. What do you mean by reversing? Right, if you have a number like, let's say 742, so reverse of that becomes 247. So we need to have such type of numbers where it should not change even after reversing the digits from front to left, I mean right to left and left to right. Okay, from front to back and back to front. And here you can see we will be having a lot of number like this. For example, if we have 747, right, this is again a number which is which does not change when we interchange the digits. But the question is, what is the smallest 3-digit number? The smallest 3-digit number, let's say go with 100. If we interchange or if we reverse the digits, we'll get 001, which is not exactly correct. 001, which is not exactly correct, right? So 888 is not the correct answer. 999 is not the, although they obey that reverse in the digits, but they are not the smallest 3-digit number. 101 becomes the smallest 3-digit number, which when reverse the digits the number does not get changed. Correct? So option D is the correct answer. Let's move for the next one. Product of two odd numbers and one even number is an product of two odd numbers. So we already have two odd numbers and one even number. So total we are multiplying three numbers here. Total we are multiplying three numbers. Okay. Product of two odd numbers. Let me take two odd numbers. Any two odd numbers. Let's say 3 into 5. And one even number. Let's try to take maybe 2. 2 is an even number. You can take 4, 10, 100, whatever it is. So 5 into 3 is 15. So 15 into 2 is again 30. 0 is also an even number. So 30 is an even number. Always, how many odd numbers it may be, you may have, but one even number is enough to make the complete product to even number. One even number is enough to make the complete answer to even numbers, right? So always it is odd. No, it can't say no. We always, you can take any other numbers, right? Let's say 3 into 5, right? Let me take 5 into 7. And on even number, let me take 6. 6 5 is 30. 30 into 7 is 210. So it is again saying that it is an even number, right? So you take any combination of two numbers, two odd numbers, and one even number. You always get an even number, and it does not depend on numbers. We always get even number which does not depend on numbers, correct? Right. So let's try to move for the next question. Which is the whole number that does not have a predecessor? What is predecessor? Predecessor is a number which comes before. For example, I have a number 12. The predecessor of this will be 11, and the successor, I told you already, right? Successor will be the number 13. So now we need to understand what is the predecessor of 100. So which is the 19, and the number before that is 99. The number before 1 is 0. Yes, we have in terms of whole numbers. We are talking about the whole numbers. For 9, we have 8. But for 0, we don't have any predecessor in whole numbers. We don't have any predecessor in whole numbers. So that is a completely wrong answer. That is completely a wrong option. So option B, which does not have any predecessor. So that will be the correct answer. Okay. So moving forward to the next one. A tire factory produces 6,348 tires a day. Okay, so these are the number of tires output that company is giving out. How many tires will the factory produce in 460 days? 460 days, right? 6348 minus into. So per 1 day, if it is 6348, for 460 days, we need to multiply with 460, right? So please try to do it quickly so that I'll give you some time and tell me the correct answer. We are making, let's say small example, you are making 5 chocolates a day, and year long you are making. So how many chocolates you are making total? 365 days, right? So 365 into 5 in the same way, 460 into 6348, that will be the correct answer. So please do it fast. So last 15 seconds. So please try to do it that fast. So you can simply ignore this 0. You just need to multiply this one or. Okay. So we have a lot of options that we can go. We'll directly go with the direct multiplication. So 6348 into 46, and then we'll keep that 0 at the end. Okay. We can ignore those zeros. So 6 8s are 48, 6 4s are 24, plus 4 28, 6 3s are 18, plus 2 20, 6 6 are 36, plus 2 38, right? And now with 4, 8 4s are 32, 4 4s are 16, 17, 18, 19, 4 3s are 12, 13, and 6 4s are 24, plus 1, 25. Once again, please cross check that if there is any calculation mistake. 8 plus 1, 10, 8 plus 2, 10, 9 plus 1, 10, 8, 9, 10, 11, 12, 5, 6, 7, 8, 9, and 2, right? So how many tires will the factory produce in 460 days is 2,92,008 tires, which is a huge number, which is almost near to 3 lakhs. 3 lakhs tires in that 460 days, 2,92,008 number of tires the factory is giving in 460 days, right? A very easy question. Let's move to the next one. What is the next question we are having? The cost of a flat is a 4218,000. So that is coming to 42 lakhs 18,000. 42 lakhs 18,000. That is the cost of one flat. Okay. If there are 36 similar flats in a building, how much money will be collected by selling all the flats? So this is the cost of each flat. And in that way, we totally have 36 similar flats. So same flat, same cost. We are not going to take any other conditions. So we need to multiply this one. Always when you have 0, 0, 0, 0, you just simply ignore that. You just try to multiply the remaining numbers. Okay. So 4218 into 36. 6 8 is 48, 6 1 6, 7 8 9 10, 6 2 is 12, 13, 6 4 is 24 plus 1 25. Right? And 8 3 is 24, 3 1 3 4 5, 3 1 3 4 5, 3 2 is 6, and 4 3 is 12. Okay, once again, let me check that. 8 3 is 24, 3 1 is 3, 4 5, 3 2 is 6, 4 3 is 12. Right. So let us add this. 8, 4, 8, 11, 2, 3, 4, 5, and 1. Right. This is not the overall cost. We still left 3 zeros. So keep all 3 zeros at the end. 1 5 1 8 4 8 and 0 0 0. So let's try to keep the commas correctly. So here with thousands, then lakhs, then crores. So 15 crores, 18 lakhs, 48,000, and 48,000. That's it. So for that 36 similar flats, each costing at 42 lakhs 18,000, the total money the total revenue or the total money that will be collected by selling all the flats will be 15 crores 18 lakhs 48,000. Right. So moving ahead for the next question. 470988 books are to be arranged equally in shelves. If 378 books are arranged in each shelf, how many shelves will be needed? Okay, so please try to do that fastly. Understand the question and understand how the books are being arranged in shelves. Then you can understand what to do. Last 20 seconds left. Right, so last 5 seconds. Let's try to stop the timer and let's try to solve the question. So 470988, 470988, and 378 books are arranged in each shelf. So you need to divide with 378. I'll give a small example. For example, you have 20 chocolates and you're arranging them in shelves such that each shelf has 5 chocolates. Each shelf has 5 chocolates. So 20 divided by 4 will give you 4. 20 divided by 5 will give you 4. 4 number of rows or 4 number of shelves are required if you keep 5 in each. Right, that means we need to divide them. So the same way we need to divide these two. Let me try that. So it is a 378 and we have 470988. So 378 once, it is 378. So we need to find the difference between these two first of all. 10 minus 8 is 2. This 6, 16. So it is 92. Right. Then we have 9. So 378 into twice or thrice. Let me check that. 378 into 3 times. Let's see. 3 is 24, 7 is 21, 20, 23, 3 is 9, 10, 11. It's way beyond the number, right? So let's go with 378 twos. So 378 twos. 8 2 16, 7 2 is 14, 15, 3 2 is 6, 7. So it is 2 times 756. So 9 minus 6 will give you 3. It is 12 and this is 8. So 1 and this is 7. 173 and then we have the next number 8. Right. So maybe 378 5 times or 4 times. We already discussed about 3 times, 4, 5 times. Let us see 378 5 times. 378 5 times. 8 5 is 40, 7 5 is 35, 4 39, 5 3 is 15, 16, 17, 18. So 1890, right? We're still ahead of that number. So let's try to decrease for 378 into 4. 378 into 4, 8 4 is 32, 7 4 is 28, 29, 30, 31, 4 3 is 12, 13, 14, 4 3 is 12, and 14, 15. 15, 1, 2. So 378 4 is 1, 5, 1, 2. So it is 6, 2, and this is again 2. 2, 2, 6. And we are left with one more 8 at the end. One more 8, 2, 2, 6, 8. Let me check that. 378, 6, sir. 8, 6 are 48, 7, 6, 7 are 42. 43, 44, 45, 46, 6 3s are 18, plus 4, 22, exactly 2268. So 378 into 6 times will give you 2268, and that will give you the remainder as 0, right? So that is, finally the answer is 1246, 1246 shelves are required to arrange all these lakhs of books, 4,70,988 books, right? So I hope I understood all the things that we have discussed in today's class. We have a couple of more questions that we are going to discuss in the coming lecture, right? So thank you so much, students. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So today we will be discussing about net force. What does net force mean? See, normally in everyday life, on any object, okay, in fact on me also, there are many forces acting, not one force, there are many forces acting. For example, on me, gravitational force is acting, force by the floor, that is also there, and there is force by air also, atmosphere also, many such cases, right? So there are many forces acting on us. So when there are many forces acting on us, then what is the total effect? What is the final effect? Or how do multiple forces behave? That is what net force is all about. Okay, so my name is Shashin Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. Let's go into a simple example here. So you can clearly see you have a lady and a man who are trying to push a door. Okay, this is a door. So the question is, will the door move towards left or towards right? The question is what? Will the door move towards left or towards right? What do you think? Yeah? Will it move towards right or left? The man here is pushing it towards left and the lady here is pushing it towards right. So what's going to happen? Now some of you might be saying, sir, towards right, some of you might say towards left. But what actually happens is, if both apply equal forces, the door does not move. It depends on how much force they are applying. If the lady applies more force, if the lady is pushing with a greater force, the door will open towards right. Whereas, if the man is pushing with a greater force, the door will open towards left. But if both their forces are equal, if both apply equal forces, the door will not open, the door will not move. Yes? So here we have different cases. Here in a simple case we have two forces acting, but this, depending on the value of these two forces, different things can happen. Yes or no? Different things happen depending on what? Depending on the value of those two forces. Right? So this is a simple case. Let's go into many such cases. Okay, so wherever you have multiple forces, that's when we define net force as. So in reality, there can be multiple forces acting on a body. Yes, right? So to find how the body moves, we define something called as net force. Now what is net force? It is basically a combination of all the forces. Okay, when I say combination, it can be addition or subtraction. So how subtraction? It depends on the direction. We'll go into that. Okay, and net force is a single force that replaces the effect of all the forces on the body. I'll explain, don't worry. And it is nothing but effective force. So net force can also be called as effective force. Now what is the third point? I'll show it to you. I'll show. So here, let's say I have a box. Okay, I have a box. Let's say these two are the same boxes. The diagram might be different, but let's say those two are the same boxes. So in the first case, I'll be applying a force 10 Newton here and let's say 15 Newton here. So in the first case, on the box, there are two forces towards right, 10 Newton and 15 Newton. Now here, in the second case, what I'll do is I'll apply one force, but which is of 25 Newton. In the first case, I'm applying two forces. In the second case, I'm applying only one force. Newton is a unit of force, okay? Focus on the values here. Now, when I look at these two cases practically, whatever happens in the first case, exactly the same thing happens in the second case. Whatever happens in the first case, the same thing happens in the second case also. What does that mean? That means the effect of the forces in the first case is equal to the effect of force in the second case. Well, these two are equivalent. You can say that these two are equivalent cases, like equal cases. Equivalent. That means we can clearly say that, or we can clearly see that here, 10 plus 15 is equal to 25. That means if there are multiple forces acting in the same direction, we add them and we get one force which is 25 Newton. So this one force is the effective force, is the net force. Okay, and what is the specialty here? The specialty is both the cases are equal and in fact almost the same. Okay, so come back to the point here, read this now. Net force is a single force that replaces the effect of all the forces on the body. So in this particular case, 25 Newton is the net force, and what is 25 Newton force doing? It is replacing these two forces. So net force replaces the existing forces, or the existing forces, the multiple forces acting on a body can be replaced with a single force, and that single force is called as what? Net force, or the effective force. Clear? So that's what the third point is about. And third point is important. Okay? Good? Okay, that's wonderful. So now, well, just give a statement. For forces in same direction, we have seen what to do. Like here in this example, 10 Newton and 15 Newton. What did we do to get net force? 10 plus 15, 25. We add the two forces. Right? So for forces in the same direction, net force is equal to sum of forces. When what does sum mean? Sum means addition. Right? It is sum of forces. But for forces in opposite directions, what happens? It is the difference of forces. What does that mean? I'll just show an example to you. Just a minute, I'll show an example. So here if I take this case, 10 Newton towards right, 15 Newton towards right. And I'll take another case. 15 Newton towards right, whereas 10 Newton is towards left. Two different cases. Here the forces are acting in the same direction. Let's call this as first case. And the second case, the forces are acting in the opposite directions. So what is going to happen? Or what is the net force? Here when they are acting in the same direction, you add them. So it is 10 plus 15. That is going to be what? It is going to be 25 Newton. But the second case, net force is going to be the difference because the forces are acting in the opposite direction. So net force will be equal to 15 minus 10, which is 5 Newton. But remember, force also has direction. Here when they are in same direction, you add them and you say it is towards the right. So it is 25 Newton towards right. But in the second case, both the forces are in opposite direction. So in which direction will the net force be? Or in simple terms, in which direction will the box move? Forget about everything else. Let's say on the box there are only these two forces, 15 Newton and 10 Newton. No friction, nothing. Only these two forces, 15 and 10. Now in which direction will the box move? Now everyone, in which direction will the box move? Very simple. The box will move towards right, in the direction of the larger force. In the direction of the larger force. So the larger force is dominant. So that means here the net force 5 Newton will also be towards right. So force is important. So here when you draw it, again if you want to draw the net force, you just draw 5 Newton, but you draw it towards right. Here it is very simple. You draw it towards right in the same direction. Both the forces have the same direction. Clear? Simple. So if the forces are in the same direction, we add the forces. If they are in opposite directions, we subtract the forces. Clear? Be careful about the direction. Okay. So we have a simple case here. We'll go into many examples. So we have a simple case here. And the question is, will the box move? So what are the forces acting here? 5F, 3F. Okay, you can think of F as a variable. That means, I'll just show an example. If F is equal to 2 Newton, then 3F will be how much? 3F will be 3 into F, which is 3 into 2, 6 Newton. What will 5F be? 5F will be 5 into 2, 10 Newton. Okay, that's how it is going to be. So F is nothing but force. So here 5F and 3F. You can clearly see if you assume an example of F is equal to 2 Newton, here that means the force acting here, 5F is 10 Newton and the force acting here is 6 Newton. The question is, will the box move when there are only these two forces? Yeah. There are two different forces acting in opposite directions. That means the box will move. The box will what? The box will move. The answer is yes. And F is equal to 2 Newton. This is only an example. Only an example. Got it? Wonderful. Chalo. Now, just a minute. Yeah. Will the box move? Yes. In which direction? Towards right. The dominant force is 5F. That is the reason. Okay. I'll take another example. This is a pretty interesting case. How many forces do we have? 1, 2, 3. We have 3 forces acting. The same question, will the box move? Now for this, it becomes interesting here. What will we do? Here, if I want to name them, one force is F1. Here, let's say F2. Here, let's say F3. Then let's try getting the net force. Let's try getting what? Net force. So how will you get net force here? For net force, these two forces are in the same direction. 2 units and 2 units. So what will you do about these two? You will add them to 2 plus 2. But this here, 4 units is in opposite direction. Opposite direction, you do what? You subtract them. So 2 plus 2 minus 4. What is that going to be? 4 minus 4. Net force is equal to 0. So if net force is equal to 0, it is similar to the case where no force is acting. I told you, right? The final effect will depend on net force. Net force is 0. That means there is, or it is similar to no force acting. So will the box move? The box will not move. No. Understood? Simple, right? So remember, in the same direction you add them, in opposite direction you subtract them, and we get the net force. Simple. Okay. Now as we understood here, we got net force as 0. but in the previous case net force was not 0. Two different cases, right? So based on that, we define something called as unbalanced forces and balanced forces. Now, what are they? Whenever you get net force is equal to 0, we say that the forces are balanced. It's just a case. That means if I take this example, 5 Newton and another 5 Newton. So in this case, I can clearly say that these two forces are equal and opposite. Net force is what? 5 minus 5, 0. So net force is 0. So these two forces are called as balanced forces. They exactly cancel each other out. But if net force is not equal to 0, then we say that it is unbalanced force. Unbalanced force. So if there is an object here, just taking a rough example, let's say one force acting is 7 Newton, the other force acting is 5 Newton. So net force here will be how much? Net force will be equal to, opposite direction you subtract them, 7 minus 5, it is 2 Newton. Is that 0? Net force is not 0, so it is the case of unbalanced force. Now what is the main difference between them? One, in terms of net force we understood. Then in terms of the effect, in terms of what does the force do? Here, in this case, will the object move? In the first case, where the net force is 0, will the object move? It doesn't. Net force is 0. Right? So here, balanced forces, they do not change the motion. They cannot change the speed, they cannot change the direction, they cannot make an object at rest move, they cannot stop a moving object, they cannot do anything to motion. So balanced forces cannot affect the motion, but unbalanced forces can. So it all depends on net force. We have to look at what? Net force. Clear? So that's why we say that unbalanced forces, they can change motion. Unbalanced forces, net force is not equal to 0. But balanced forces, net force is equal to 0. So they cannot change motion. They cannot affect motion in any way. Clear? Okay, good. So there is simple difference between balanced and unbalanced forces. What are balanced forces? Balanced forces, net force is 0. Unbalanced force, net force is not 0. Then again, balanced forces, they cannot affect the motion of a body. But unbalanced forces, they can affect the motion. They can make a body start from rest. They can increase or decrease the speed. They can change the direction of motion. All of that. Okay. But there is an interesting point here. Net force is 0. That is balanced forces. They can change the shape of the object. How? I'll give a simple example. If you take a sponge, and if you apply equal forces per se, if you apply equal forces of 5 Newton and 5 Newton. Now in this case, what is net force? Net force is 0. But will the shape of the sponge change? If you press the sponge from two sides, two opposite sides, will the shape of the sponge change? It will. Yes? The shape of sponge changes. So here you have a case of balanced forces because net force is 0, but the shape changes. That means balanced forces can change the shape of the object. They cannot change the motion, but they can change the shape of the object. And unbalanced forces, they can, because net force is obviously not 0. So unbalanced forces, they can also change the shape of the object. So both balanced as well as unbalanced forces can change the shape of the object. Clear? Okay, wonderful. So let's go into a few examples then. I'll be giving you time, so please solve it. Find the net force from the following diagram. This is the diagram. What is the net force? Everyone. 10 seconds. 10 seconds should be enough to solve it. What is that? What is the net force? Here, look at the direction of forces. You have a force 8 Newton. 8 Newton towards right and another 8 Newton towards left. So when you look at the directions, they are in opposite directions. So to get net force, if forces are in opposite direction, you subtract them. 8 minus 8, 0. 8 minus 8, 0. Clear? So net force is 0 Newton. That's it. Next question. Find the net force from the following diagram. Again, the same question. Yeah. Do it again, 10 seconds should be enough. You have two forces again. So what is that going to be? Yeah? That's what again 8 plus 6, 14 Newton, because here the two forces 8 and 6 are acting towards right. Same direction. So you will say that if they are in same direction, you add them, it is 8 plus 6. So it is going to be 14 Newton. And which direction? Yeah? Both of them are towards right. So both of them or the final force will push towards right. So 14 Newton towards right. Clear? Okay. Another question. Find the net force from the following diagram. This is an interesting question. You have three forces. So I'll give you 20 seconds of time. So please solve it. 20 seconds should be enough. Because it's ultimately addition and subtraction, right? Simple. Find the net force from the following diagrams. 8, 10 and 12. And time is up. Time up. So what is the answer going to be? The answer is 6 Newton. How? I'll tell. We have three forces here. So net force, how will you get it? These two forces are in the same direction. You add them. And this force is in opposite direction, so you subtract them. What do you get? You get 18 minus 12. 18 minus 12 is 6 Newton. So net force is equal to 6 Newton. The question is, in which direction? In which direction? In which direction is a larger force? Towards right. So you'll say that it is what? It is towards right. Now, or else there is another way of doing it. Another way, same way, but in detailed step. I'll show it to you. If you have the box, there are the forces 8 Newton and 10 Newton. You have another force here which is 12 Newton. Now, this I can reduce it to what? Eight plus 10, what is that going to be, everyone? If you add, these two are same direction. So let us first add these two forces, 8 plus 10, it is going to be 18 Newton. And here it is how much? 12 Newton. There are two forces in opposite directions, 18 Newton and 12 Newton. Okay. Then what? 18 minus 12. Now you subtract them. Doing it in this way, you will have no confusion about the direction. Between 18 and 12, which is the larger force? 18 is the larger force. So when you go for it, 18 minus 12, you get 6 Newton, but direction will be towards right. See, so we are doing it in a detailed step-by-step process. Then we'll get the direction also very clearly. Okay? In fact, it is the same steps that we have done here. Not anything different. Okay, so we get the same answer finally, 6 Newton towards right. Clear? Okay. Next. Find the net force from the following diagram. It's an interesting case. Here it is not right left, here it is up and down. So what is the net force in this case, everyone? We need the direction also, not only the value but the direction also. Yeah. The direction also. What is that going to be? So here again you can clearly see one force is upwards, one force is downwards. They are in opposite directions. So you subtract them. Net force is equal to 8 minus 5, which is 3 Newton. We got the magnitude, we got the value. What about direction? The larger force, the dominant force is upwards. Right? So that means it will also be upwards. You have to look at the larger force. You have to look at the greater force. Here it is 8 Newton, which is upwards. So 3 Newton will be upwards. Clear? That is net force. Simple? Okay. Then another question for us. Again, this is again interesting. Because here these two forces now are not towards right or not towards up, left, down. They are along an inclined plane. So you have a box on an inclined plane and two forces are acting. So what is the net force? What is the direction? Find the net force on the following diagram. Ignore all the other forces like gravity, friction and all. Ignore them. So what is it going to be? Yeah? Do it. Take your time, do it, solve it. Two forces, 8 Newton and 17 Newton, 17. So what is that going to be? Right, so it's again very simple. If you look at 8 Newton and 17 Newton, they are in opposite directions. So if they are in opposite directions, what will we do? We'll subtract them. Do not think of anything else. In opposite directions, you subtract them. 17 minus 8. How much is that going to be? 9 Newton. Am I correct? Yes? Okay. What about direction? For direction, I have to draw the diagram. If this is the inclined plane, if this is the box, direction will be along the larger force. 17 Newton is the larger force. It is downwards along the incline. So you just draw that here. Okay. So that will be what? 17 minus 8. It will be 17 minus 8. What is that going to be? 9 Newton. We got 9 Newton already. We have done the calculation. So 9 Newton net force along the larger force. Clear? Okay, that's good. So another question here, one final question for today's class. A box is placed on a table. What forces act on the box? Draw a diagram. So this question is about different type of forces acting. We will not be finding net force. So there is a box placed on the table. Let's say this is a table. So what are the forces acting? Yeah, everyone, what forces will act? Imagine if you have a table in front of you. Let's say you have a book. Place a book on the table. What are the forces acting on the book? Yeah? One will be gravitational force. Who will apply gravitational force? Earth. Gravitational force by Earth. Then there will be another force, we call it as normal force, because it is perpendicular to table. Who will apply the force? The table will apply on the box. So normal force by the table. That's it. There are two forces. End of story. Okay. This is the diagram. Simple diagram. Clear? Okay. Another question. In a tug of war, two teams are pulling a rope and the rope does not move. Explain why. The rope is not moving. Now why? Because it's very simple. Both the forces are equal. Net force is equal to 0. Or you can say the forces by the teams, the forces by the two teams are equal and opposite. Are equal and opposite. So they cancel out. So we get net force is 0. And if net force is 0, the rope does not move. It does not move towards left or towards right. Simple explanation. Many of you would have played tug of war. Yes or no? Right? That's what happens. If both the teams have equal force, the rope does not move, no one wins because the forces cancel out. Clear? Okay, so that's it everyone. That's it for today's class. We learned about net force. We learned about how to find out net force as well as its direction. Okay, thank you. Thanks a lot.